Okay, so hello everyone, welcome to our presentation. As you may know, economic growth is an important topic in macroeconomic, and it helps us understand why countries have different levels of wealth. And today, our team will introduce to you the Solow model and using calculus to analyze it. So in general, the Solow model provides us a simple but effective way to analyze the key determinants of economic growth in the long run. Here, you can see that Solow focuses on three key elements, including capital, labor, and also technology. And also for the scope of the project, so we'll hold labor and technology constant to understand more about the dynamic of capital on economic growth. So here, then we employ four main concepts of math, especially derivative, so that we can find the golden rule steady state where consumption is maximized. Now, Anji will help you understand more about the model.
So in the Solow model, there are two basic functions, the cost-veloc production function and the law of motion capital function. We also have three important aspects of the economy from two functions above. This is depreciation function and production function and investment function. From the graph, we can see the straight line is depreciation function. The second one is production function, and the last one is investment curve. Next slide, please. So in economics, the steady state is equilibrium between capital per worker and depreciation. And this can be found when KT equal with KT plus 1, with T is discrete time. It means that at the steady state, capital per worker times T equal with capital per worker at time T plus 1. And in the graph, we can see the red line, the intersection between the depreciation curve and investment curve is at the steady state. Next slide, please. So now we are finding the consumption per worker in the steady state. We know C star is the total consumption of a worker at the steady state and is equal with their income minus their saving. And this is the function 1. So in the graph, we can see the red line, the gap between output curve and the saving or investment curve is the consumption per worker at the steady state. So we substitute 2 into 1 and we have the consumption per worker in the steady state as follows. So next slide, please.
As G mentioned before, we have steady state consumption per workers as a function of saving rate S as shown here. So we will use the derivative to find the saving rate where the consumption is maximized and then substitute into the steady state condition to find the optimal capital per worker. Now we find the first derivative of consumption with respect to the saving rate S by chain rule. Then we find the critical bond by finding the saving rate where the derivative equals to 0. Finally, we got saving rate equals to alpha, with alpha is the elasticity of output with respect to capital. And based on the steady state condition, the corresponding capital per worker is KT equals gamma per alpha to the power of 1 over alpha minus 1. And we can see in the table on the right that at its capital per worker, the consumption per worker reaches its maximum. Now, anh Dũng will discuss some limitations.
So there are two main limitations of the model. First is the actual genius saving rate. It means that we don't allow saving rate to vary over time, but in reality, savings tend to change based on historical and expected interest rate. Another thing is about holding constant labor rate. Normally, we need to allow both labor and technology vary to understand more about the dynamic of the model. However, due to our limitation in terms of mathematical knowledge, so we need to fix it. So that's basically the two limitations that our model has. Thank you for listening.